This video is designed to demonstrate how to use SPSS to conduct a one-way analysis of variance. For this example, we'll use the education data and we'll be comparing the three classroom sections on their average Quiz 3 score. And so the classroom sections are labeled sections 1, 2, and 3. And so you can see in variable view how these sections, how this label is set up. And section is also considered a independent variable or a factor because it has three levels or three separate groups. Our dependent variable in this case is quiz, and quiz is a scale or interval level variable that ranges from 0 to 10. So a research question we could pose for this analysis is, do classroom sections differ significantly on average Quiz 3 scores? Now what we should do first is run our explore analysis to determine if the Quiz 3 scores are significantly non-normal by group. So if we go to Analyze and Descriptives, we can go to Explore, and we can move section into the factor list. That's our independent variable. In Quiz 3, into the dependent list. And so in order to be able to know if these variables, if Quiz 3 scores are significantly non-normal, then we go to Plots and we can click on Normality Plots with Test, and we're interested in the test. So we go Continue and OK. And so we of course can see all the descriptive statistics like the mean and the standard deviation, but we'll look at those later. But we can see that with the Shapiro-Wilks test that all sections of Quiz 3 scores, or all Quiz 3 scores by section, are significantly non-normal. However, what we do know is, like with the t-test, we can violate one of our assumptions. And in this case, if we violate the assumption of normality, then we cannot violate the assumption of homogeneity of variances. So we can check our homogeneity of variance assumption when we do our ANOVA analysis. So I'm just going to close our output. I'm not going to save it. I know our variables are significantly skewed. And then I'm going to start the ANOVA analysis. And I'm going to go to Analyze, Compare Means, and One-Way ANOVA. And so our dependent variable, again, is Quiz 3. And our independent variable is section. Or our factor is section. And keep in mind that the one-way ANOVA analysis, the first part of this analysis just tells us if the groups are significantly different or not. If the ANOVA is non-significant, then we don't need to go any farther. But if the ANOVA is significant, then we have to conduct a post hoc test. The post hoc tests tell us if which groups differ significantly from one another. In this case, we have three sections, and we want to know if those three sections, do they all differ significantly on mean Quiz 3 scores, or just do two of the groups differ significantly? And so if we click on post hoc, we can choose a post hoc test. I like to choose the Tukey test, and I'm going to choose that because it's one of our most conservative tests, and it definitely helps to protect against making a type 1 error when saying that the result of the ANOVA analysis is significant. Then I'm going to go Continue, and then for options I'm going to click Descriptives, and then I want the homogeneity of variance test because I want to know if we've met that assumption. So I will click that, and then I'll click Means Plot because that's going to visually give us a plot of the Quiz 3 means by each class section. And then I'm going to go Continue, and then I'm going to go OK to run the analysis. So we can see here each of our sections, the number of students in each group, and the mean and the standard deviation. We can see our Levene's test here is not significant because this probability is way over 0.05. So luckily, we don't have to worry that we violated two of the three assumptions for the ANOVA analysis. If we come down here, we can see that our ANOVA is significant. Our F ratio is large, and so what this tells us, this first part, is that at least there's one significant difference between groups among the three groups that we analyzed. So in order to determine which groups are significantly different, we come down here and we look at the post hoc tests. And so this first comparison, set of comparisons, looks at comparing section 1 to section 2 and section 1 to section 3. And so we can see that the difference between section 1 and section 2 is on average 1.38, almost 1.4 points on quiz 3. And notice that that value is asterisk. And what that means is that the comparison is significant. So section 1 is significantly higher than section 2. So if we go up here and look at section 1, the mean is 9 compared to section 2. This 1.385 difference between these two groups is significant. And then the same way with section 1 and section 3. There's a difference of 1.394. It's on average, it's asterisk, and it's significant as well. So we can see that the average of 9 points by section 1 is significantly higher than the average of 7.61 points by section 3. The next set of comparisons looks at comparing section 2 to section 1 and section 3. Well, we know that 1 and 2 are significantly different. We see it here in this comparison. But then section 2 and section 3, very, very minute difference between those two groups. And of course, this is not a significant difference. In other words, what they've done is in this multiple comparison is compared section 2, 7.62 to section 1, 7.61, and that difference is 0.009, which is very small and non-significant. And then when we come to the third set of comparisons, these are redundant because this comparing section 3 to 1 and 2 has been captured in these first two sets of comparisons. The other way we can look at comparing these groups is using the homogeneous subsets comparison, and notice that sections 3, their averages are in the same column. And so they do not differ significantly from one another. But then we have section 1, it's in its own separate column, meaning that this average score for section 1 is significantly higher than the average scores for section 2 and section 3. And then this is a plot for the means. And so you can see section 2 and 3 are down in this area where section 1 is clear up here at on average of 9. So I hope this has helped you to understand how to run an ANOVA analysis using SPSS. And if you have questions, please feel free to contact me so I can help to clarify.